Hello there. So these are the list of questions that we are going to cover in this video. I've covered all the related concepts already. Please check this playlist out to know more. And now let's get started. But before we get started with the first question, let me quickly create a new package or folder, and let's name this package as basic questions. Now I'll use this package to create classes to write code. So the first question is pretty simple. It is to print hello world on the screen. So let's create a Java class and let's name this Java class hello world. And what we have to do over here is, first of all, have the main method where all we have to do is print hello world on the screen. And we know how to print something on the screen, right? We can make use of system.out.println, and we can say within a pair of double quotes, hello, comma, world. And that is it. And if I run the code, what do we get? Well, we get hello world printed on the screen. Now, moving on to the next question, which is to add two numbers. Let's create a Java class first, and let's name the class as add two numbers. And over here as well, we will have a public static void main method. And here, what we need to do is we need to add two numbers. So we will need to create two variables to store those numbers, right? So let's do that. We'll say int num1 and we will say int num2. Now, in order to put values in these variables, there are two ways. One, you can use literals and you can say num1 is equal to 10 and let's say num2 is equal to 20. And then you can say int sum is equal to num1 plus num2. And then lastly, you can say system.out.println sum and you can run the code. And this will give you 30. The other way is to take input from the user. So taking input, as we know, is a three-step process. Step one is to import the scanner class. And we can do that by saying import java.util.scanner. Then the next step would be to create an object of scanner class. And we can do that this way. We can say scanner and then scanner. By the way, this can be any name because this is an identifier. So we'll say new scanner system.in. Now, once we have the object of scanner, what we can do next is we can use the methods defined in the scanner class to take input from the user. So we're going to take an integer input from the user. So what we should be doing here is we should be saying scanner.nextInt. Then over here, we'll do the same. We'll say scanner.nextInt. Once we have these two numbers, the rest of the code will work as it worked earlier. So if I run the code now, we can see that nothing is getting printed and the program also has not completed because it is waiting for us to enter a number as an input. So let's say I put 20 and then press enter. It is still waiting because the code needs two inputs and we have given one yet. So we'll say 30 and then we will hit enter and this will print 50. So let's make it a little more interactive and let's say system.out.println, and over here we can say please enter a number. And then we can do the same thing for the second number. We can say please enter another number. And now if I run the code, this will say please enter a number. We will put say 20 and then it will ask for another number. We'll say maybe 16. And if I hit enter, I get 36. So this is how we can take two numbers as an input and add them. On to the next question, which is to find average of three numbers. And for that, let me create a Java class. Let's say the name of the class is average of three numbers. Now over here, we will need a main method, of course. And here what we need to do is find the average. And to calculate the average, we will need to have three numbers. And then what we will have to do is find the sum of the three numbers and divide that by 3, right? So let's get that done. The first thing we will do is, of course, have three numbers. So let's say I take int num1 is equal to 10, num2 is equal to, let's say, 12, and num3 is equal to, say, 8. Then what we need to do is we need to find the sum. For that, we can say int sum is equal to num1 plus num2 plus num3. And then in order to find average, what we can do is we can say int average is equal to sum divided by 3. And then lastly, we can print the value of average. Now in the last question, which was to add two numbers, and in this question, which is to find the average of three numbers, what we have done is we have taken integer inputs. But of course, the numbers that we need to add or we want to add could be a decimal number. In that case, we can take float or double as a data type of the variables which will store those numbers. And we can do the same thing over here. And here we should do that because we are going to find average where we will divide the sum by 3. Now, if sum is a multiple of 3, there won't be anything after decimal, right? But if sum is not a multiple of 3, for example, if sum is 10, the average will be 3.33, right? In that case, float would be a more suitable data type. So let's change this to float. But there's another problem over here, which is sum is int and 3 is also of int type. Now, division of one integer or one int by another int is going to give us an int. And even if we have average declared as float type, we will still get something 0.0. Let's try this out first and then let's see how can we mitigate that. So right now we have got 10, 12 and 8. The sum is going to be 30 and if I go for 30 by 3, I'm going to get 10. And we're getting 10.0 because we have stored it in a float variable. But what if I make this 10 as 11? Now we have got 31 as a sum. 31 by 3 would be 10, 1 by 3, which is 10.33, right? But let's run the code and see what do we get. Well, we get 10 again. And that is because sum is integer. So 31 by 3 is going to give 10 only. And what we are doing here is we are storing 10 in a float variable. So 10 stored in a float variable would be 10.0. So to mitigate that, what can we do is we can either have sum as a float or we can say divided by 3.0f. And if I do that, first of all, the yellow line vanished. And if I run the code now, I'm going to get 10.3333. So with this, we solve the third question. And the next question is to calculate area of a circle, for which we will create a new Java class. We will say area of circle and we will have the main method over here and we will start writing code. But first, a little bit of maths recap. What is the area of circle? Area of circle is pi r square, right? Now r is the radius and radius could either be an integer or a decimal number. So what we will do is, to be on a safer side, we will take float and we'll say float radius. And let's put a random value over here. Let's say we put 3.5 f. This f over here is because 3.5 without an f will be treated as a double literal. If we put an f over here, this will be treated as a float literal. Now, like in the case of add two numbers, we can go for all these three steps where we imported the scanner class. Then we created an object of scanner class. And lastly, in step number 3, we took input from the user with the help of the object of scanner class. But what I'm doing here is not taking input from the user and instead hard coding the values. And that is because the purpose of this video is to understand how to take a question and then convert that into a code that solves the question. So with that said, let's continue. Now over here, what we need to do is we need to find the area. And we know that area is pi multiplied with radius multiplied with radius. Now we have the value of radius here in the variable radius. What about pi? We know that pi is equal to 3.14, which is a decimal number, and that is why I'm taking a float variable. So we'll say 3.14f, and then for area, what am I going to do is I'm going to uncomment this first of all and declare a variable called area of type float, and this statement will give us the area. And over here, I forgot to put a semicolon. Now, let me just print the value of area and see what do we get. We got 38.465004. Now, if I open calculator and I say 3.14 multiplied with 3.5 multiplied with 3.5, I will get 38.465. But over here, I'm getting 38.465004. Now, why is that happening? That's a totally another topic of discussion, and I'm going to make a video on that as well. But for now, just understand that this is happening because of how Java stores decimal numbers. So with this, we complete the fourth question. And now moving on to the fifth question, which is to find the area of rectangle. For that, let's create a Java class. Let's name this as area of rectangle. And here as well, we'll quickly have a main method. And then to find the area of rectangle, what is the formula? The formula is length into breadth or width. So what do we need is, we need two variables to hold length and breadth and one variable to hold the value of area. So let's take float as data type of the length variable and let's put say 3.5, and then let's take float as a data type for the breadth variable and let's say 5.5. And of course we'll have to put f over here, and then we'll be able to find the area by going for length multiplied with breadth. And if I print the value of area, what do we get? Well, we get 19.25. Now let's also extend this code to find the perimeter. So what will be the formula of perimeter? First of all, to find the perimeter of a rectangle, we can go for 2 multiplied with length plus breadth. And we can say float perimeter is equal to 2 multiplied with length plus breadth. And lastly, we can print the value of perimeter. And if we run the code, we get 19.25, which is the area, and 18, which is the perimeter of rectangle, given the length is 3.5 and breadth is 5.5. So do you notice a pattern over here? All of these questions that we are solving involves identifying what the input would be, then processing those input, and finally getting the output. And this is what you would have done had you been given these questions as math problems. For example, if you were to find area of rectangle, what you would be given is length and breadth. And the length and breadth would either be given to you directly, or you would have been able to derive it with a sub-problem that is a part of the question itself. And something similar applies to coding. When you solve a problem by using any programming language, what you do is you try to break down the question such that you're able to identify what inputs would you need. Now that input can either come from the user, or that input can of course be hard coded like we are doing over here. But either way, you will need an input. Then you'll need to know how to process those input in order to reach the output. For example, in this case, the input was length and breadth. And in order to find area, we know that we'll need to multiply length with breadth. And how do we multiply something in Java? We use this operator. Similarly, to find perimeter, what we need is, we need length and breadth, which we already have. Now we also know the formula for finding the perimeter, which is 2 multiplied with the sum of length and breadth. So the next thing is how to put that formula in code. So what did we do was, we used a few operators. This one for multiplication, this one for addition, and the parenthesis. Now parenthesis over here is used to alter the operator precedence, because without parenthesis, what would happen is the multiplication would go first and then the addition will happen, which is not something we want, right? And you see the output is different. What we want is, we want to add first and then multiply. So similar to solving math problem where you need to know the concepts and only then you'll be able to solve a given question, here as well, you'll need to understand the concepts related to a programming language. It can be any programming language. In this case, it is Java. So you need to know the concepts, and then once you're familiar with the concepts, you can apply those concepts to solve a problem. So with all of this said, let's move on to the next question. But before that, let me change the name of the class, because we're not calculating just the area, we're also calculating the perimeter. So let's rename this to area and perimeter of rectangle. Now, the next question is a temperature in Celsius to Fahrenheit. For that, let's create a new class and let's say Celsius to Fahrenheit. And here, let's have a main method. Now, first of all, we need to know the formula, right? Which is temperature in Fahrenheit would be equal to temperature in Celsius multiplied with 9 by 5. And all of this would be within a pair of parentheses, and then we'll go for plus 32. So knowing this formula, let's first of all have a variable of float type, and let's name this variable as Celsius. And we can say, for example, 32. Then in order to find the temperature in Fahrenheit, we can say C, which is Celsius, multiplied with 9 by 5 plus 32. So we can say Celsius multiplied with 9 divided by 5 plus 32. And we will end this with a semicolon. Now, this pair of parentheses has got an expression, and the expression is to multiply Celsius by 9 and then divide by 5. Now, Celsius is already in float, but what if I change it to int? You see a yellow underline, and this will be saying Celsius multiplied with 9 by 5 is integer division in a floating point context, which in simpler term means that the entire expression is going to give you an int result. But what are we doing is we're storing that int in float. So even if there are decimals, that will get truncated, and ultimately we will get just 0 after decimal point. So if I change it back to float, the error will vanish. And now if I just print the value of the variable Fahrenheit, we should get the result. And here it is 89.6. Now recalling from, I think class 6, 7 or maybe 8 science, minus 40 in Celsius will be the same in Fahrenheit, which is what we are getting. So this is how you can convert from Celsius to Fahrenheit using Java. Again, this is similar to the maths problem or the physics problem you would solve, where you have some input, then you use some formula to get to the result, and then you finally get the answer. Over here, you're printing the output. Next up is to calculate simple interest, for which we will create another class and we will say simple interest. Again, let's create a main method and let's think of the formula or recall the formula first. And the formula for simple interest or SI is P multiplied with R multiplied with T divided by 100, where P is the principal, that is the amount on which the interest is being imposed. R is the rate of interest per annum, and T is the time in years. And this will be divided by 100 in order to get the interest amount. Now, in order to get the amount, what we will have to do is go for principal plus simple interest. So what do we need? We need principal, then we need rate of interest, and then we need time. So let's create 3 variables. Let's say float principal, and let's set this to, for example, 10,000. Then we'll go for rate. Rate is, for example, 6.3% per annum. And then time is, let's say, 3 years. So what we need to do first of all is find the simple interest. And the simple interest would be principal multiplied with rate multiplied with time. What is time? Multiplied with time, and then to find the amount, we'll say principal plus simple interest. Now let's print both the values of simple interest and amount, and let's run the code and check the output. Wow, the principal interest is 189,000 for principal of 10,000, and that is because we forgot to divide by 100. And that is why when you code, it's very important to be careful about the code that you're writing, because wrong code will of course give you wrong result, and in some cases it can be catastrophic. So let's run the code again and we get 1890. Now this seems fair, and the amount is 11,890 at the end of 3 years. Now let's move on to the next question, where we will calculate total cost after applying 18% tax. For that, let's create another class. Let's name this class as total cost with tax. And let me close all of the other tabs that I have to the left. So PSVM, which is public static void main. And what do we need to do is we need to find the total cost. So total cost is the price plus 18% of the price. Now over here, what do we need? We need price, of course. That is the only input we need to find the total cost. So what we will do is we'll have a variable called price of type float, and we'll say, for example, 1050.50. Then we need to find the total cost. Now total cost, as we know, is price plus 18% of the price. But how can you write 18% here in the Java code? Now we know that 18% is 18 divided by 100, right? Which is 0.18. So you can either write 18 by 100, sorry, not 200, 100 multiplied with the price. And here, of course, we'll have to make either of this as a float. Otherwise, what's going to happen is this will be integer and this will also be integer. And then the division of integer by integer will give you integer, which in this case is going to be 0. So if I just leave it at that and I print the value of cost, what am I going to get? Well, we're going to get 1050.5, which is because price was 1050.5 and this resulted in 0. So to make either one of them float, what you can do is either you can go for 18.0f and then run the code, or you can go for, as you might have guessed, 100.0f and then run the code and you'll get the same output. So this is how you can translate this formula in this code. Now for the next question, which is given bank balance and the withdrawal amount, what you need to do is you need to find the fee that is implied, and the fee is the 2% of the amount that is withdrawn. And then you'll have to calculate the remaining balance at the end. So for that, let me first of all create a new class and let's name this class as remaining bank balance. And over here, we'll have a public static void main. The problem is to find the remaining balance, right? Which is equal to the initial balance. Then from the initial balance, we will withdraw some amount, right? Which will be the withdrawal amount. So we had some initial balance from which we withdrew some amount. Say we had 10,000, we withdrew 1,000. So what is it going to be? It is going to be 9,000. But there's also a processing fee or some charge that is being applied, which is, say, for example, 2% of the withdrawal amount. So what we will have to do is we will have to subtract 2% of withdrawal amount as well. Now over here, if you take a look, what do you need? You need two inputs. One is the initial balance and the other one is the amount that you're withdrawing. So let's get started by creating two variables. The first one would be initial balance. Let's say it is 10,000. And then the withdrawal amount, which is going to be, say, 1,000. Then you need to calculate the remaining balance, which will be initial balance minus withdrawal amount minus 2% of withdrawal amount. And we know how to calculate 2% here in Java, right? What we can do is we can go for, say, 2.0f divided by 100, and this will be multiplied with the withdrawal amount. Now, if I print the value of remaining balance, what's going to happen? Well, let's find out. So if I check, we are getting 8980. And is this correct? So 10,000 minus 1,000 will give us 9,000. Then we need to subtract 2% of 1,000. Now 2% of 1,000 is 20. So we are going to get 8980. And this is what we got as the output, which means the output is correct. And over here, the way this expression is written takes care of the precedence of the operator that is required to perform this expression in correct way. But if you want to be sure, what you can do is you can put this entire expression in a pair of parentheses. So what's going to happen is this is going to get executed and then this entire expression is going to get executed. So this serves two purposes. First, which is not applied here, the parenthesis will alter the operator precedence, and also it provides clarity as to which expression should be evaluated first. So with this, we solve this question of finding the remaining bank balance. And now on to the next question. The next question is to find the BMI, that is the body mass index. And to find the body mass index, the first thing that we will do is create a class, of course, body mass index, and we will say public static void main. Now the formula of finding BMI is weight in kilograms divided by height in meters multiplied with height in meter. Now this multiplication, that is the height square that you see over here, should be together. So it is like weight divided by height multiplied with height. So what do we need over here to find BMI? We need two things. We need the weight and the height. So let's take weight first. Let me put 70 and then let's put height. So height should be in meter. So we'll say float height is equal to, let's say, 1.7 meters tall. Then if we were to find BMI, what am I going to get? We'll say BMI is equal to weight divided by height multiplied by height. And then we'll say BMI. So if I run the code, I get 24.221453. Next up is to calculate the birth year by knowing a person's age and the current year, of course. So for that, let's create a class. Let's name this class as calculate birth year. And over here, we'll say public static void main. Now what we need to find is birth year. And how can we do that? Well, we can take the current year and subtract the person's age from the current year. Now over here, tell me how many inputs do you need? Do you need two inputs, that is the current year and the person's age, or you need just one input because the current year is a known information, right? So what are we going to do is we are going to take just one input, which is the age of the person. So we'll say int age, and let's put the age as, for example, 22. Now, in order to find the birth year, what we can do is take an int variable and we can say int birth year is equal to 2026 minus 22. And if I print the value of birth year, oh, I'm sorry, I should have put age here and not 22. So if I run the code now, it will print the birth year, which is 2004. And this is how we can find the birth year by knowing a person's age. So this taught another important lesson, which is whenever you need some input to do some operation and then get some output, it may happen that some of the input are commonly known information. For example, the current year in this case, where you won't need to take an input from the user. Moving to the next question, where we are going to find the number of years left for a person to retire. And for that, we will create a Java class and we will say years until retirement. Here we'll say public static void main. Now what do we need to do is calculate the number of years until retirement. And what is that going to be? Well, we will need to know what is the age in which a person retires. So let's take that to be a fixed value, 60. And we will also need to know the person's current age. So we will need person's age. And with this formula, we can find the number of years left until retirement, right? So let's go for person's age. And let's say the person's age is 40. Then the next thing that we need to do is create a variable and let's name that variable as years until retirement, and we'll say 60 minus person's age. And over here, we will print the value of years until retirement. And if I run the code, I get 20. Now, what if a person is already 62? Well, that will give us minus 2. And what does this mean? This means that the person has retired already 2 years ago. So with this clear, let's move on to the next question. And the next question is to take minutes as input and convert that into hours and minutes. So let's see how can we do that. But for that, let's create a class first and let's name this class as minutes into hours and minutes. First of all, let's have a main method. Now let's see if we have total minutes. Let's take an example. Let's say we have got 340 minutes. How many hours are 340 minutes? Well, it is 5 hours and how many minutes? 40 minutes, right? How did I reach this answer? Pretty simple. We can go for 340 by 60 because we have got 340 minutes and each hour has got 60 minutes. We can go for 340 by 60. Now, when you divide 340 by 60, you're going to get two things. One, a quotient, and the other one is a remainder, right? The quotient is going to give you the hours. So quotient will give you hours and the remainder will give you the minutes, right? So what we have to do is we have to take only one input, which is the number of minutes. So we can say int, say total minutes, and we can say 340. Then we need to divide 340 by 60. And no matter what the value of total minutes is, it will always be divided by 60. Since 60 is a fixed value over here, what we can do is we can go for, say, int hours is equal to total minutes by, which is slash 60. That is, this is going to give us the quotient, that is the number of hours. And for number of minutes, what we can do is we can go for total minutes mod 60. And lastly, we can print hours plus we can give a space and print minutes. And if I run the code, I get 5 and 40. That is 5 hours, 40 minutes. if I change this to say 360 minutes and then run the code, what am I going to get? We are going to get 6 and 0. 361 and we are going to get 6 and 1. Now let's take this a level up and let's calculate the number of hours, minutes and seconds given number of seconds. So for that, let me first of all create a Java class and let's name this Java class as seconds into hours, minutes and seconds. And let's also have a main method. Now, first of all, let's figure out the formula for this. So let's say we have got 210 seconds, or let's take a bigger value. Let's say we have got 40,000 seconds. Now, if we have 40,000 seconds, how many number of minutes is this equal to? For that, we can go for 40,000 divided by 60, right? So if we do that, we will get 60 into 6, which is 360, 40, and then another 0. 60 into 6, again 360, then 40, another 0. 60 into 6, 360, and then we will have 40. So this is 666 minutes and 40 seconds, which means 40,000 seconds will be 666 minutes and 40 seconds. Now what you need to do is you need to convert 666 into hours and minutes, right? And which we already know how to do. What we can do is divide 666 by 60, and that is going to give you the number of hours that are there in 666 minutes and the number of minutes that are there. And this is going to be equal to 11 hours. So 660 minutes and 6 minutes, right? So finally, what do we have? We have 11 hours, 6 minutes, 40 seconds. And we were able to find that by dividing the total seconds that we have by 60, and that will give us minutes and seconds, and then dividing that 666 or the number of minutes that we got by 60, which will give us hours as quotient and remaining minutes left as remainder. So with this clear, let's write the code. So let's say we have got total seconds is equal to 40,000. Now the first thing we will need to do is find the number of minutes, which will be equal to total seconds by 60. And we need to find the number of seconds, which will be total seconds mod 60. Now, once we have the number of minutes, what we can do is, and this actually is not just minutes, this is total minutes. Now with total minutes, what we can do is we can find the number of hours, and that can be done this way. This will be total minutes divided by 60, and then remaining minutes, which will be again divided by 60, but this time we will be collecting the remainder. And finally, we can print hours plus, let's give a space over here, minutes plus seconds. And if I run the code, I get 11 hours, 6 minutes and 40 seconds. So this completes this question. Now for the next question, we need to find the last 3 digits of a 5-digit number, and then we need to add those 3 digits to get their sum. So let's first of all create a Java class and then name this Java class as sum of last 3 digits of 5-digit number. Pretty long name, but this serves the purpose. This tells us what this class is about. Now let's first of all think how can we do that, and of course only then we will be able to write the program. So let's take some number and figure out how can we find the last 3 digit. And we will start that by figuring out how can we find the last digit. So let's take a look at this number. This is 52168, right? And this is in decimal format, which means 8 is at position 0, 6 is at position 1, 1 is at position 2, 2 is at position 3, and 5 is at position 4. Which means the value of 8 here is 8 multiplied with 10 power 0. The value of 6 here is 6 multiplied with 10 power 1. Of 1 is 1 multiplied with 10 square. Of 2 is 2 multiplied with 10 cube. And of 5 is 5 multiplied with 10 power 4. Which means this is 50,000. Then this is 2,000. This is 100. This is 60. And this is 8. And when you add all of these, what do you get? Well, you get this number, right? Now take a look at this and tell me if there's something you can do with this such that you only have 8 left. Well, yes. And what we can do is, if we have got 50,000 plus 2,000 plus 100 plus 60 plus 8, and you divide all of this by 10, what are you going to get? You're going to get 50,000 by 10, which is 5,000. Then you're going to get 2,000 by 10, which is 200. Then 100 by 10, which is 10. Then 60 by 10, which is 6. And 8 by 10. So you see, all of this will get completely divided by 10 except 8, which means if you divide all of this by 10, you're going to get this as the quotient and this as the remainder, right? And what do I mean here is, of course, this 52168 divided by 10 will leave you with 5216 as the quotient, and that will give you 52160 here and 8 as the remainder. So if you've got 52168 and you want to find 8, which is the last digit of the number, what you can do is divide that by 10 and collect the remainder. And that is how you will get the last digit. But what about the second last digit? How do you reach there? Pay attention to whatever we did over here. When we divided 52168 by 10, we got 8 as the remainder. But what was the quotient? The quotient was 5216, which is this part of the number. Now, if you take the quotient and you divide that quotient by 10 again, what are you going to get? You're going to get 6, right? Because 6 now is the last digit of this number. So essentially, you'll be getting the second last digit of the original number. And if you perform that same operation again on whatever you get as the quotient of dividing 5216 by 10, which is going to be 521, you'll get the third last digit of the original number, right? So how are we going to solve this problem? Well, what are we going to do is, we're going to take a number and we're going to divide that by 10. So if we do that, we get a quotient and a remainder. Then we take that quotient and we divide that by 10 again. So this will give us 521 as the quotient and 6 as the remainder. And then you take this and divide by 10 again. So you will get 52 here as a quotient and 1 as the remainder. So this way you'll be able to get the last digit, the second last digit, and the third last digit of the original number. And once you have these 3 digits, you can just add them together, right? So now let's come to IntelliJ. Let's take a number in a variable called number. Let's take 52168 and let's start the operation. So the first thing that we're going to do is create a variable called, say, quotient1. And here we will say number divided by 10. Then we will have remainder 1, where we will say number mod 10. Now this remainder 1 is going to give us the first digit. So let's rename this and let's say first digit. And we can keep quotient 1 as it is for now. So we've got first digit in this variable. Now for the second digit, what we will have to do is perform the same operation on quotient 1, right? So what we can do next is find quotient 2. And this quotient 2 will be quotient 1 by 10, right? So we had 52168. If we divide 52168 by 10, we're going to get 5216. And the first digit will be 8. Then over here, this will give us 5216 by 10. And that 5216 by 10 is 521. And then the second digit is going to be quotient 1 mod 10. And this will be 6. Then we will do the same process. We'll say quotient 3, and this is going to be equal to quotient 2 divided by 10. And quotient 2 is 521. So divided by 10 is going to leave us with 52. And then we'll get the third digit. And this is third digit from the last, like this is second digit from the last and first digit from the last. So this will be quotient 2 mod 10. And we are going to get 1. Now, once we have these 3 digits, what we can do is add them up, right? So Let's first of all have a separate variable where we find the sum. We'll say first digit plus second digit plus third digit. And here we'll say S out sum. And if I run the code, I get 15. Is this the correct answer? Well, it is, because 1 plus 6 is 7 plus 8 is 15. Now if I change this to say 52,000 and then I run the code, it will be 0. If I change this to say 12111, this is going to be 3, and that's correct. Then let's move on to the next question, which is extracting the first and the last digit of a 5-digit number and finding the product of the first and the last digit. So for that, let's first of all create a Java class, and let's name the Java class as product of first and last digit of 5-digit number. And we'll have public static void main, and we will take a 5-digit number first of all. We'll say, for example, 52168. Now over here, we know how to find the last digit, but how do we find the first digit of a 5-digit number? So going by the example that we had taken here, what we can do is, if we have got 52168, to find the last digit number, we can go for 52168 mod 10. That is, collect the remainder and you have the last digit. Now, in order to find the first digit, what you can do is you can follow the same steps over here until you reach this point where you have got 52, which you are dividing by 10. Now, if you do that, you'll get 5 as the quotient and 2 will be the remainder, right? Now, over here, 5 is the first digit of this number. Or there's another way. What if we divide this by 10,000? If we divide this by 10,000, we will have 5 as the quotient, right? And the remaining 2168 as the remainder. And why did I choose 10,000? Well, that's because it is a 5-digit number. That's why. If this was, say, a 3-digit number, 521, I would have divided by 100. You see the pattern, right? So if this is an n-digit number, what will we do is divide this by 10 power n minus 1. Now, having known that, what we can do, straight up 52168 by 10,000, this will give us 5 as a quotient. Now add this, or actually multiply this with this, and you have your answer. So let's write the code. Let's have a variable called first digit, and let's say number divided by 10,000. Let's have another variable called not second, last digit, and we'll say number mod 10. And then we'll have a variable called product where we'll say first digit multiplied with last digit, and then we will print the value of product. And if I run the code, I get 40, which is the correct output. And if I change this to, let's say, 42168, I should get 32. And that's what we got. Now let's move on to the next question, which is finding the sum of digits of a 3-digit number. And for that, let's first of all create a Java class, and let's name this Java class as sum of digits of a 3-digit number. And here we'll have a main method. Now let's first of all think of a logic which we can apply over here. So for that, let's take a number. Let's say 1, 2, 3. Now in order to find the sum of digits of this 3-digit number, you'll have to find the individual digits, right? And now we already know how to find individual digits. What we can do first of all is divide 123 by 10. The quotient over here will give us 12, and the remainder will give us the first digit, right? Which is 3. Then if I go for Q1 by 10, the Q2 that we have is going to give us 1, and the remainder that we have will give us the second digit, which is 2. Then when we divide Q2 by 10, what are we going to get? Q3, right? Q2 is 1, 1 by 10 is 0, and the remainder that we will have is R3, and this R3 will be 1, and this will be the third digit. And this, by the way, would be R2 and not R3. So this way we can get the first digit, the second digit, and the third digit. And once we add these 3 digits, we will have the sum of digits of the number, right? So what we have to do is we have to go for 3 divisions. In each division, we will collect the quotient and the remainder. The remainder that we collect will be added at the end to get the sum of digits of the number, and the quotient that we collect will be used for further division. And we will keep on doing that until we reach a point where the quotient is 0. In this case, however, the number of times we do it is going to be fixed. We are going to do it 3 times. Or we can actually stop after the second division, because the first division will give us the last digit and the remaining 2-digit number. Now, once we divide this 2-digit number, the quotient will give us the first digit of the original number, and the remainder will give us the second digit of the original number. So if I take a variable called number and I assign it, say 123, what is the first digit going to be? The first digit is going to be number mod 10. Now, what is the remaining number going to be? The remaining number is going to be number divided by 10, right? We can switch this around, have this as the first step and this as the second step. Anyway, to find the second digit, what are we going to do? For second digit, we're going to say remaining number divided by 10 and collect the quotient. And for the third digit, what are we going to do is the remaining number mod 10. And then we'll find the sum by going for first digit plus second digit plus third digit. And then if I print the sum, what should I get? I should get 6, right? And we got 6. If I change this to say 712, I should get 10, and we got 10. Of course, if the number of digits increases or decreases, the number of times we do this will increase or decrease, right? So with this, we've solved the question where we were expected to find the sum of digits of a 3-digit number. So let's move on to the next question, which is to reverse a 3-digit number. For that, let's first of all create a Java class, and let's name this class as reverse a 3-digit number. And over here, we'll say PSVM, which is public static void main. We'll take the number, let's say 567, and let's first of all think how can we reverse a 3-digit number. Now, for that, let's take a 3-digit number, 567. Then, if we reverse, the answer would be, so this is ones place, tens place, hundreds place, and when we reverse, what's going to happen? It is going to be 765. So the 7, which was at ones place, will be at hundreds place. The 6, which was at tens place, will remain at tens place, and 5 will be at ones place. So what do we need to do? It's pretty simple. We'll have to extract the first digit, the second digit, and the third digit. Now you must have noticed that I'm using first digit, second digit, and third digit in a way interchangeably. That is, in this case, I'm taking first digit as 5, which is the first digit from the left. In another example, I took the first digit from the right, or essentially the last digit of the number, as the first digit. But don't get confused. The primary objective over here is to extract the 3 digits. You can store it in a variable, say A, B, and C, and that won't matter. Now with this discussed, we already know how to extract the digits, right? So once we have the digits extracted, what we can do next is, in order to find the reversed number, what we should be doing is, we should be multiplying whatever we have in third digit with 100, right? Because as you can see, whatever we have in third digit should go to the hundreds place in order to reverse the number. So we will say third digit multiplied with 100 plus second digit multiplied with 10 plus first digit multiplied with 1. So with this clear, let's write the code. So first of all, we'll need to find the 3 digits that we have, right? So let's find the third digit as in 7 in this case. That is the first digit from the last. So this will be third digit equal to number mod 10. And then the remaining number is going to be number by 10. So this will be 56, right? Then let's find the second digit. The second digit would be the last digit of 56 and the second digit of the original number. So we'll say second digit is equal to remaining number mod 10 and we'll also find the remaining number again. So let's name this as remaining number 1 and this one as remaining number 2. And this is going to be equal to remaining number 1 divided by 10. And this is going to give us 5. And this actually can be our first digit, right? So we can say first digit. Then what do we need to do is reverse it. So we'll say reversed number. And as we have discussed, what's going to happen is the third digit contains 7. That 7 should be multiplied with 100, right? So we'll say third digit multiplied with 100 plus second digit multiplied with 10 plus first digit multiplied with 1, or you can leave it as first digit only. And then if we finally print the value of reversed number, what do we get? We get 765. If we try this out with, let's say, 701, for example, we're going to get 107. What if we try this with 700? What are we going to get? Well, we are going to get just 7. I mean, ideally, it should be 007. Just 7 is also fine because we are going for integer arithmetic. And if we multiply something with 0, that becomes 0, right? Anyway, this is how we can reverse a 3-digit number. And of course, this goes without saying because you already know. If the number would have been a 4-digit number, for example, the steps would have been similar, but the number of steps would have been more. Now let's move on to the next question. And the next question is swapping two numbers by using a third variable. So let's first of all understand the question. The question is, let's say I've got one variable, say num1, and this contains 15. And then we have another variable, say num2, and this contains 20. Now what we need as the output is, when we print num1, we should get 20. And when we print num2, we should get 15, right? Now how can this be done? Well, of course, the starting point would be taking two variables and storing values in it. Then in order to swap, we need to do some operations. Now, what operation would that be? Think of it for a moment, but think of it as buckets instead of variables. So if I've got one bucket which contains 15 and I've got another bucket which contains 20, and what I want to do is I want to interchange the value that each bucket contains. What I can do is I can put 15 over here, right? But if I do that, I will get 15, but I'll lose 20, correct? So what we should be doing is we should be storing 20 in a different place. In a way, make copy of it. So if I take another bucket and if I copy 20 over here, then what's going to happen when I copy 15 over here? The 20 will get overwritten, right? And that is expected. But we did not lose that value because we have stored that value somewhere else also. So now what we can do is we can take this 20 from here and we can put it in the first bucket. In that case, what's going to happen is 15 will get overwritten with 20, right? And then finally, we can print the values that are there in these two buckets. Now, if I translate the same thing to variables, what would that look like? Well, what did we do first was we stored 20 in a different bucket. So we'll take another variable. Say we take temp. And what we do is we make a copy of num2. And then what are we going to do is we're going to say num2 is equal to num1. So what are the steps going to look like? The steps would be this. First of all, you make a copy of num2. Then since you have a copy of num2 already, now you're ready to overwrite the value of num2 with whatever you have in num1. So you can say num2 is equal to num1. With that, temp will have 20, num1 has 15, so num2 will have 15, and then you can say num1 is equal to temp. So what's going to happen is whatever was there in temp, which is 20, will get stored in num1. So you see, we started with num1 15 and num2 20. Then we went for temp is equal to num2, which means we stored 20 in temp. Then we went for num2 is equal to num1. So what is there in num1 at this moment? It is 15. And that is getting stored in num2. So this will get replaced with 15. Then we are saying num1 is equal to temp. What do we have in temp? We have got 20. And 20 is getting stored in num1. So num1 will have 20. And this is how we can swap the values of two variables with the help of a third variable. So let's write code for this. For this, the first thing that we will do is create a Java class, and we'll name this as swap values of two variables with help of third variable. And we'll have a public static void main, and we'll take two variables, say num1 containing 15, and we'll take num2 containing 20. Now, what were the steps? The first step was creating a variable called temp and creating a copy of, say, num2. Of course, you can create a copy of num1. The steps will change a little bit, but the logic is going to be the same. So once you have a copy of num2, now you're ready to replace num2. Now you can say num2 is equal to num1. And lastly, you can say num1 is equal to num2. So if you print num1 a space and then num2, what are you going to get? You're going to get 15 and 15. Well, I clearly messed up somewhere, and the mistake is here. I should have said num1 is equal to temp. And when I run the code, I get 20 and 15. Now, if I copy the print statement and paste it here and then run the code, what do I get? I'll get 15 and 20, which is what the initial values of num1 and num2 are, as the first line of the output. And then I'll get 20 and 15, which is the value that we get using the same variable in the same order after we performed swap. Now, what if you would have done, say, int temp is equal to num1 instead? So if you do int temp is equal to num1, you are in a way making num1 free such that it can hold another value because you have made a copy of num1 in temp. So the steps would change a bit. It will be num1 is equal to num2 over here. And now you already have replaced the value of num1 with whatever was there in num2. So here is the turn of num2 to be assigned the value that was originally in num1. So if I run the code, I expect to get the same output, and we are getting the same output. So this is how you can swap the values of two variables with the help of third variable. Now the question arises, is it possible to do so without the help of third variable? Well, yes, it is. And that's what we are going to do next. And for that, we're going to create a class, and we will name the class as swap values of two variables. And instead of with help, we'll say without help of third variable. And I'm going to copy this method entirely, paste it over here, and I'm going to remove this logic for now. So we'll say num1 is equal to 15 and num2 is 20. One way is this. You can say num1 is equal to num1 plus num2. And this will give you 35 in num1 and 20 will stay in num2. The next step would be num2 is equal to num1 minus num2. So num1 is 35 minus 20 will give you 15. So num2 will have 15. Then the next step is num1 is equal to num1 minus num2. Now num1 has got 35, num2 has got 15. 35 minus 15 will give you 20. So you see, we started with 15 and 20 in num1 and num2 respectively, and we ended up with 20 and 15 in num1 and num2 respectively. So this is how we can swap the value of two variables without using a third variable. And let's put the same logic in code. For that, we're going to go for num1 is equal to num1 plus num2. And this, of course, will not be int num1 because num1 has already been declared over here and you're using the same variable. So this is the first step. The second step is num2 is equal to num1 minus num2. And the last step would be num1 is equal to num1 minus num2. And now if I run the code, I get 15 and 20 as the first line of output and 20 and 15 as the second line of output, which means this logic is working perfectly fine. Now, this is one way of doing it. Another way is to replace the plus that we have in these three steps, which is only in the first step, with multiplication and minus with division. So if I do that, Let's see what is the output that we get. Well, we get 15 and 20 as the first line of output and 20 and 15 as the second line of output. So these are the two ways in which you can swap the values of two variables without the help of a third variable. Now in this video, I'm not going into the details of the magic that's happening over here. But if you want me to, please let me know in the comment and then create a separate video explaining the logic that is making all of this happen. And this brings us to the end of the video. And in this video, we have covered a few questions on the basis of whatever we have covered so far. And if you want to take a look at whatever we have covered so far, you can access the playlist by clicking over here. The purpose of this video was to get you into the habit of writing code to solve some problem. So far, we did write code, but then those code was mostly to understand the concept that we were going through. In this video, however, we have put all of those concepts into practice. So I hope I've been able to teach you something new and useful. If you have any suggestions, feedback or queries, feel free to put them in the comments. Thank you so much for watching and I'll see you in the next one.